Hi everybody, Mr. Vidich here. Welcome to lesson 4 of our systems unit. Today we're going to learn a new method to solve linear systems, and that's called elimination. Last class we learned how to do the method of substitution, and today we're going to learn a new method. Now both methods you will need to know because sometimes the method of elimination can be much more quicker to solve two systems of equations, while substitution might take a really long time. However, on the other hand, the method of elimination is not going to work all the time, depending on your two equations, or three, or however many you have. So I'm going to take you through a few examples here. Go ahead and read these steps, and I'm going to kind of walk you through these steps as I do this first example. So we have our system of equations here. So we have equation 1 and equation 2, and using the method of substitution from last class, we would have to isolate for x or y and then substitute that into the second equation to get a third equation where we can finally solve for our unknown variable. Now that takes a long time. It could take a long time, and that's why we have this new method of elimination where we might save some time here. So here's how the system or the method works. All right, once we have our two equations, we can either choose to add them or subtract them depending on what the signs are here. So the first thing you want to do is you want to make sure you have at least one of the variables the same. So in other words, I have my y's here, and I have 7 here and 7 here. Once you get to that point, you can go ahead and either add or subtract. Now, let's just see what I mean here. If we added this equation, the bottom one to the top one, we would get 5x, and then plus 7 adding negative 7 would eliminate the y's, so we would get 0y, and then we would get 15 over here. Okay, and now I just go ahead and solve for x. X equals 15 divided by 5. X equals 3, and then again you would now substitute that 3 back into either equation to solve for y. Let's go ahead and do that off to the side here. So 6 plus 7y equals 13. 7y equals 7. Y equals 1. So that's my solution. X equals 1 and y x equals 3 and y equals 1. Now, why did I choose to add? Well, if I chose to subtract here and not add, I would have ended up with a negative 1x, and then I would have gotten 7 minus negative 7 would have actually given me plus 14y equals, and then 13 minus 2 would be 11. Now, do you see how I didn't eliminate either of my variables? So I didn't really help myself out here. I still have two variables. So the goal here, just like the method sounds, elimination, is to eliminate one of the variables using either addition or subtraction. Now, if this 7 was positive, then I could have subtracted, and that would have worked. Okay, and again, you know once you get your solution here, so x equals or I can just write it as xy coordinates 3, 1. You can go ahead and verify both solutions, both equations, to see if that solution does work. I'll let you go ahead and check that. Okay, so let's go ahead and use this method now. Okay, now for this method, for example 2, I do see both my x variables are positive, so I will have to subtract the bottom one away from the top one to get rid of the x variables. Now, one thing I do want to say is make sure that you line things up according to their like terms here. So I need to have x's here, y's here, and then the coefficients here. Okay, you cannot have x's here and then y's underneath them. That you can't add x's and y's. So you got to make sure you have like terms here. Okay, so let's go ahead, and again we're going to subtract the bottom equation away from the top one, because that will get rid of our x's. So 2x minus 2x, well, that just gives me 0x, so I won't even write anything down. Now 6y minus 3y here gives me 3y, and 6 minus 4.5 gives me 1.5, and then y equals 1.5 divided by 3, or that's just 3 over 6, or 1/2. Okay, so y equals 1/2, and then again you would just substitute y equals 0.5. I will substitute that into either of the equations. Let me go ahead and do that up here. So 2 times x plus 6 times 0.5, 6 times 0.5 equals 6. Well, that's going to give me 2x plus 3 equals 6. 2x equals 3. x equals 3 over 2, or x equals 1.5. So my solution is 1.5 comma 0.5. All right, and again, you can verify both by plugging these numbers in for your x and y values. Okay, let's go ahead and do a few harder ones now. All right. Now look at this system over here. Now if I add and subtract here, nothing, I won't eliminate anything. Let's say if I added the bottom one, I would get 6x and 2y, and that's not going to help me. Or if I subtracted it, I still wouldn't be able to eliminate anything. So there's one extra step you have to take for this one, and that is you have to make sure that your terms, either the x or the y, are the same. Okay, because they need to be the same if I'm going to eliminate them. So if how can I make the coefficients here the same? So I have a 4 here and I have a 2 here. So what can I do to make those two the same? Well, I can multiply the top equation by 2, multiply everything by 2. Of course, you need to multiply everything by 2, and that should get me to where I want to be. So now let's go ahead and do that. So now if I multiply everything here by 2, I'm going to get 4x plus 6y equals 8, and that's the first equation up there. And now the second one is 4x minus y equals 22. I don't have to do anything to the second one. And look at that, just by multiplying it by 2, I can now go ahead and do my again, I'm going to go ahead and subtract the bottom one away, because that's going to get rid of the x's. And now be careful here with the sign. So 6y minus y is actually 7y. 8 minus 22 is going to give me negative 16, or 14 rather. And then y equals negative 2. And then again, you need to now find the x. So I'm going to substitute the negative 2 back in for y. So it's going to be 4x. Let me do that in green. 4x plus 6 times negative 2 equals 8. 4x minus 12 equals 8. 4x equals 20. X equals 5. So there's my solution, and you can write it as an ordered pair here. So you can go 5 comma negative 2, and that. So visually on the graph, when you graph both of these equations, this is the coordinate where these two lines are going to intersect. Okay, now let's go ahead and do one more example here, a couple more actually. So let's look at this example here. This one's a little bit awkward because I have 5 and a 3, and a 3 and a negative 7. So it's not, I can't just multiply anything by 2 or divide by 2. So I have to take an extra step for this one to get my terms to be the same. Okay, I'm going to go ahead and just focus on the a's here, and make sure I can get them the same. So what will make this the same? Well, there's one simple kind of way to do it. You just find the lowest common multiple between the 5 and the 3, and in this case that's going to be 15. So I'm going to multiply the top by 3 and the bottom one by 5, and what that's going to allow me to do is get both of the a terms to be the same. So it's going to be 15a plus 9b equals 9. That's the first equation, and the second equation is going to be 15a minus 35b equals 405. And then again, now once you have your coefficients the same, you can go ahead and eliminate the a's by subtracting the bottom one from the top one. So I'm going to go ahead and let you do that and see if you can get to the answer. I'm going to jump right to the next example here. Okay, solve the following system using elimination. So again, it always helps. Now look at this. They're not written in the same order. So if you write them like this underneath this one, so 3x equals 5y plus 26, and you try and eliminate stuff, it's not going to work because you need to line things up vertically. You want your x's here, your equal sign in the same spot. So this is not going to work. So you have to rearrange it for it to work. So let's go ahead and do that over here. It doesn't have to be, you can choose any order you want as long as it's consistent with both of your equations. So let me go ahead and rewrite this now. Over here, 4x plus 2y minus 13 equals 0. And then for the second equation here, I want to rearrange it so it looks the same. So 3x, and then it's going to be negative 5y minus 26 equals 0. Okay, and that's okay as long as you know, everything's in the same spot with the top one. And now again, you would make sure you find your lowest common multiple, and that, you know, in this case might be to multiply this top one by 3 and the bottom one by 4. So, you know, a few extra steps here to get us set up here, and now we finally get 12x plus 6y minus 39 equals 0, and then on the bottom we're going to have 12x minus 20y minus 104, I think, equals 0. So now we go ahead and subtract, and that's going to get rid of the x's, and we're going to get 26y plus 143 plus 65. And again, be careful with your signs here. It's negative 39 plus 104, so 65 equals 0. And then we're going to get y equals I think it's negative 2.5, negative 2.5. And then again, you would have to go back and just like you did for substitution, and find your x by plugging in the y either here or here, or on the original equations would also work here or here. That might be easier. Okay, I'm not going to go ahead and do that. I'm going to jump to this last example, this hard one here that involves fractions. Again, you need to make sure everything's consistent. Now, the one thing I would do is get rid of my denominators because that's just going to make my life easier. So again, multiply everything by 15 here, 15, 15, 15, and that's going to get rid of the denominators. That's going to be a 5, that's going to be a 3, and that's going to stay as a 15. So it's going to be, now make sure you put my brackets around here. So it's going to be 5x minus 10, and then it's going to be, watch this negative here, so negative 3y minus 6 equals 30, and then it's going to be 5x minus 16 minus 3y equals 30, and then finally 5x minus 3y equals 46. Okay, so I have to do a little bit of work to get this, to get this where I want. But again, that's nothing new here. We know from our polynomial the unit how to do this. And this one is just going to take a little bit longer over here. I'll do it in green. So what's my common denominator here? It's going to be 10. So 10, 10, 10. That's going to turn into a 2. That's going to turn into a 2. That's going to turn into a 5. So now we have, and then again, you have coefficients in front of the bracket. So 2 times 3. That's going to turn into a 6. 2 times 4 is going to turn into a 8. And again, negative 8 here. And then 5 times 21. So now I can finally go ahead and do my distribution. So it's going to be 6x plus 6 minus 8 y, and then plus 24 equals 105 over here. And then finally 6x minus 8y. That's going to be 30. 6 plus 24, and subtract 30 from 105, it's going to be 75. And then finally now I can line them up. I'll bring this one over, so 6x minus 8y equals 75. There's my first equation. There's my second equation after all that work. And again, they're not the same, so I need to multiply them to get them to be the same. So that's going to be multiplied. How do I get this 5 and 6 to be the same? Well, their lowest common multiple is 30. Actually, this might be a little bit easier to do this. The 3 and the 8, its lowest common multiple is 24. I guess it's probably about the same amount of work, so it doesn't really matter. But let's go ahead and do that. So how do I get the 3 to 24? I'll multiply that by 8 and multiply the bottom by 3, and now it's going to be 40x minus 24y equals 8 times 40 is 320, 8 times 6 is 48, so 368. And then for the second equation, I have 18x minus 24y equals 225. Okay, now I'm going to add these because they're both the same sign here. So negative, subtract because they're both negative, and I need to get them to be to eliminate them to get to be 0. So 40 minus 18 is going to give me 22x, and then negative 24 minus 24 is going to get rid of that, and then 368 minus 225 is going to get me 143, and then divide that by 22, x equals 6.5. Okay, and go ahead and just to keep the video a little bit short. Now, I would not substitute this 6.5 into the original equations because that's going to be a little bit more work to solve for y. I would pick my simplest equation, which is this one over here. Let me highlight it for you. This one over here, or this one, okay, and put the 6.5 in there to get my y. Okay, let me go ahead and just quickly do that while I'm here. So it's going to be 5 times 6.5 minus 3y equals 46. And again, you can go ahead and solve for y and get your final answer. Okay, so thanks for watching, guys. And again, like I say, this method might be a little bit quicker than substitution, but it's not going to work all the time. For example, if you had a squared, let me go back to the original example here. If any of these terms is a squared term, like if this is x squared, you cannot subtract x squared minus x because they're not like terms. So if you had a squared term, you would not be able to use the method of elimination as easy as you would substitution. So again, both methods have their advantages, so you do need to be comfortable with both methods. Okay, thanks for watching, and see you next time.